Hi everybody, my name is Pierre-Yves Ricau. I'm an Android engineer at Square. The company was renamed Block, but the organization that I work in is still named Square. So you might be familiar with Square through our open source work, especially on Android. But so I'll refer to the company as at Square because I've been there 10 years, and so for me it'll always be Square. So today we're going to talk about interaction latency, a user-centric mobile performance metric that we set up for ourselves. And I want to talk about, why we did that, what it means exactly. We're going to talk about that over the next 20 minutes. But for a second, I want to talk about what happened when I joined Square. So when I joined Square, and that was 10 years ago, we used to do what we called a testing party before every release. And so the name party, actually at the beginning, sometimes it was 4 p.m. and would actually be drinking beers, optionally, not everybody had to. But it was named a party because we would get together and test the app as much as we could right before release. And so at the time, anytime we would find bugs, we would file them and fix them. But also, if there was a performance issue, we would notice it and we would fix it. And that was how much, that was everything about performance was just if you see a problem, look into it, reproduce it, fix it. And that was it. We didn't do anything further than that. And it worked. And I think it works still today for most apps where the apps are pretty simple. You just play with it on maybe a low-end device. And then that's it. You find the problems and you fix them. But the problem is our application grew. We had more screens, more features, more engineers writing more code. And we started having very complex combinations of settings and having customers use really large databases and really complex accounts. And that meant that it became impossible to anticipate every single situation that was going to happen in the in real life to our customers. So that was a problem because all of a sudden we would have customers reaching out through support saying, I have a performance problem, and we had no clue what was going on. We didn't even know that was happening. So we realized, and they would send us videos from their phone. They would record something with their phone on our devices and send it to us. And we would be clueless as to exactly how that happened because that was not happening to us. So we realized we needed to do something about this. And what we did was we needed to measure what was happening in production. Because we needed to understand the experience of our customers, and we didn't have the ability to test and QA everything beforehand, given so many combinations. So we stopped and we asked, what do we need to measure exactly? So many options, right? So we looked at what happens in the server world, and typically in the server world, you monitor one or both of two things. Number one is resource usage. Those things like CPUs and memory, and how CPU utilization and how your memory is doing, or the heap size for a JVM. And we found that this is super interesting when you're trying to investigate a problem that you've identified. But it's not going to tell you much about the experience your customers are having. If you're doing a CPU intensive work, you should have a high CPU. But is using a lot of memory bad? Sometimes yes, sometimes it's fine. And it doesn't really necessarily translate to an actual problem that the customer is experiencing. So the other way that performance is monitored server side is with tracking workload durations and more specifically, usually traces. So, for a backend, you have HTTP requests, which are kind of the entry point, and then you see where you spend time in various parts of the system. But for mobile, HTTP requests are only a subset of what actually happens on the device. And we could, for example, measure how long a database query takes. That's useful, but that's not what the customer actually experiences. The customers, they don't really care about network requests and database queries. They care about how they use the app and what happens when they tap in the app, right? When they interact with it. So again, this type of information is very useful for investigating once you've identified a problem, but it's not that useful for understanding what is the experience of our customers. So we landed with something that we call user-centric performance metrics, which, it's a bunch of words for something that's going to be pretty obvious, which is metrics that measure the actual experience of using the application. And we're talking about the performance side of it here. So the key idea is that it's going to help product teams make better investment decisions. When is it time to focus on performance and where? Because one of the things that happens, if you go and tell the product team, hey, your CPU usage is really high, you need to fix that. The answer might be, that's cool, but we have all these features to build. How do I know exactly how important this is? Like, is this really important? How do I figure, like, I care about my customers, and how do I know what my customers are experiencing? And so it's hard to go to directly correlate CPU usage, memory usage, those kind of resource space, or how long it takes to make a database query, to correlate that with the actual experience. So what do we mean by user-centric performance? When you think about that, there's sort of like two categories for user-centric performance. Number one is smoothness. So that's everything that has to do with motion. So think animations, scrolling, flinging, playing videos. So the key question there, the key thing you want is the motion janky? And that essentially translates to, are we able to render every frame, which on a 60 frame per second display is, do we have 16 milliseconds to render? And humans' brains are really good at picking up motion and changes in motion. So if you miss a frame, people notice. And our hardware today isn't fast enough that we can skip frame without people noticing. So when you care about smoothness, you essentially have to never miss a frame. But the other broad category is what we call responsiveness, or what's called responsiveness. And that's actually very different. So it's this idea that you're going to do an action on a system, on the screen, and you're going to get a response. For example, if I wave at someone, and they're looking at me, they will take a little bit of time before waving back. It's not instant. They don't do it in 16 milliseconds, right? And so responsiveness is the delay between a user action and a visible response from the system. And that is actually very different from smoothness. The thresholds we have are much higher here. So I'll just get back to that later. So responsiveness, if we were to try to explain that with pretty pictures, our brain wants to tap on the screen, right? So it directs our finger to tap on the screen, and then the phone receives that, and then the phone updates the UI and the display shows the new screen, and then our eyes receive that and they communicate that information to our brain. So the what we call the responsiveness is really the thing that's in this rectangle, the pink rectangle here. It's the time from the finger touching the screen to the display being updated. We can't really change anything on the brain side and the speed of light and the eye side so far anyway. So if we want to measure responsiveness, we're trying to measure the real time anyway. We would measure this actual time from touch of the screen to display updated. So let's talk about thresholds. There was some studies, UX studies, that try to figure out how good our humans are at picking up those variation in responsiveness of the system. And so they found that when you're touching a screen, specifically when you're touching a display, you can detect performance changes that are below 69 milliseconds. So that means if we're able to have a responsiveness of 69 milliseconds or less, then there's no point improving anymore. So I'm talking here about, not just your part of the software, but the entire system and the hardware and everything. So that's cool. Here's the link to the actual paper. But the reality of today is, in a lot of cases, we can't actually be that fast, even though 69 milliseconds is a lot of time. So the actual threshold that you should use is contextual, because humans are pattern matchers. We are really good at detecting outliers, and our expectations are based on our past experiences. So, for example, for a web page load on your phone, you'll probably used to some amount of time. I can't guess. I don't know what your phone is, but you'll notice you'll have sometimes you say, "Oh, this page is slow to load," right? And sometimes you'll feel like you won't notice it just fast enough. But if you had a different phone and you were in a different country with a very different connection, you would have totally different expectations because it's based on what you're used to do. Similarly, app launch, which is, I tap on an app icon, how long until I actually see a useful screen and not just the logo of the app. For the app launch, it's all based on expectation. I mean, it should be instant, but clearly it's not. It usually takes a few seconds today when it's a cold start, right? So again, our expectations here are different than from loading a web page. And another example would be tapping on a like button in a social media app. Usually you expect that to be instant and the counter of number of likes increases immediately, right? And you don't really have the same expectation for app launch and tapping like. So it's interesting. It really shows that the thresholds we should target are contextual, essentially based on people's expectations, which is based on their past experiences. So I talked a little bit about that in this blog post. I'm not going to go over all of the details, but if you want to dig more, you can copy this link. And then I talked about how to track app launch on Android in production, but I won't talk about that today. So let's go back to the customer experience. So we've talked about user-centric performance metrics in general, but for Square, my company, what is the thing that we want to track? So a lot of companies will track the app launch, because if you're Twitter and if I'm, trying or Mastodon or Blue Sky or I guess it's not Twitter, it's X now. Oftentimes when I'm reading those things, I just have like a couple minutes and I want to just scroll and entertain myself. And if the app takes a couple seconds to load, I'll be just like, okay, I'm done with this. I'm just moving on to something else. And so for those apps, app launch is very important. But for Square, not that much, because our customers typically, because it's a point of sale, what we do, which I forget to mention, but we essentially build Android and iOS apps that are point of sale applications. And so they start at the beginning of the day, and honestly, they can take a little bit of time to load because then they stay on all day. So it doesn't really matter how long it takes to start. Similarly, with a social media app, scrolling is very important. But for us, we don't have that much scrollable content. Scrolling and motion isn't that important. We also don't have many pages where the loading time, like a web page, is important. We don't have fresh content that's constantly changing. However, the one thing that's very, very important for us is that we have cashiers and they're interacting with the device all day. They're trying to enter, orders from people. People are trying to check you out. And so this has to be quick. And as you do the same thing over and over throughout the day, muscle memory is a key part of these interactions. You are just, the buttons here, you need to tap here, tap there, tap here, tap there. And so because of that, these taps, the system needs to react to these taps fast. If it somehow freezes in there, that's very bad for the customer experience, and they will notice and they will not be happy. So this is sort of why this is the thing that is important to us. It's those steps and the reaction of the system. It should be quickly responding. So we call this interaction latency, hence the title of this talk. So how do we measure this in practice? So the first stab at this might be, when we have an on-click listener, we're going to start a timer before, do the work, start a timer after, and we know that we've updated the UI, right? That sounds reasonable. But it turns out it's actually not reasonable because, or actually it's very inaccurate, because when you tap, the system picks up the motion up event, sends it to your app. Your app might be busy doing something else. And then eventually your app is free. It goes, okay, I'm going to dispatch this. Then I'm going to invoke the on-click and maybe update the view hierarchy. But that's not enough yet, because then the system goes, oh, it's time for the next vsync where we're going to display what's the latest on the screen. And it's going to ask your app to do that. But your app might still be busy doing other random things. And then eventually the app gets to the rendering part, and that gets sent back to the system, and then the display is updated. So the total interaction latency is a lot more than just the on-click. So how do we measure interaction latency? Unfortunately, there is no good API from Apple or Google or SDK for this today. I'm including all of the observability vendors that you know about. No one is really figuring that out or has a good API. And that's mostly because Apple and Google haven't really provided good APIs for this. So the way that we've done that is by hooking into the touch dispatching pipeline for the start of the interaction latency. And then once we know we've updated the UI with the right content, we hook into the frame rendering pipeline to know when that's displayed. So I wrote about that maybe 2 years ago. That was the beginning of my research into this, and then made an experimental library. The code is there more to show you how it could be done. This library also does other things than to necessarily use it, but I wanted to put it out there to show how we're exploring this. On iOS, we figured out a way. We're not open sourcing anything yet, but because we're still iterating. But similarly, you have ways to look at the touch event and the main thread loop and when things get rendered. One interesting point, though, is how do we aggregate these metrics? So the way we do it is we just compute the P90 of those interaction latencies, and we group it by hardware type. So because we make our own hardware on Android and on iOS, there aren't that many options. It's nice to compare because then it's the same hardware and you can sort of compare the experience for its given hardware and by app version. But one thing to be careful with using percentiles is that it means that the events that happen the most are going to be, of course, overrepresented. And so if a single user is using the app 10 times more than another user, their data is going to influence the app 10 times more. The results 10 times more. And sometimes, so for us, that's what we want, because the users that use it more need the app more. They're our biggest customers. But for you, you might want something different, do it like per user. So there's this great talk from Hanson Ho that talks about sampling bias. Let's talk about threshold for a second. We essentially decided to go with what's defined by web.dev/INP, which stands for interaction to next paint, which is very similar to what we call interaction latency. And so essentially our threshold is anything under 200 milliseconds is fine. 200 to 500, that's not great. We should work on it. 500 is pretty bad. The difference with interaction to next paint is that we also want to, we don't include just the next frame necessarily, the next paint. We have interactions where we show a loader, and we do want to measure the end-to-end as well in those cases. So a little story very quickly. When we released this, I can't show you the exact data, I know that, but essentially I noticed that version over version, look at the red bars here, that's the P90. It jumped at some point in time. And so it was a really long investigation to figure out, but we were rolling our own Android hardware with our own Android, fork. And it turns out that some kernel configuration was impacting the memory bandwidth. So the speed at which you can write and read from memory is actually dynamic. And so the OS had stopped controlling that, and it was always reading and writing to memory at the slowest speed, which was impacting things. The other thing that I like to talk about is how we added memory usage to these metrics. And so this is an example of a session. So we see memory usage as we move around the app. And so when you graph the interaction latency correlated with memory usage, you can see that everything's fine until memory gets close to the memory threshold, because the GC is running all the time, and we're running out of memory. And so the UI starts freezing as the GC is freezing everything. So really interesting, because it tells you if you run out of memory, you're not going to get an out of memory error. You're going to get freezes, and users are going to kill the app. So that's it. So thank you so much for watching this. You can find me on Mastodon and androiddev.social/@py, on Blue Sky, p-y.wtf, and my website is p-y.wtf. Thanks a lot for your time.